Hello everyone. In this video, I am going to talk about property drawers. Property drawers are scripts that define how a particular class is going to be drawn inside your default Unity inspector. In our previous videos, we saw how we can write custom inspectors to define exactly how a variable or a class is going to be shown inside the Unity inspector. But if we have a big project and we have a large number of custom inspectors, writing the writing how to draw each variable and each class can become a really tedious process. So to solve that problem, what we can do is define just once how a class is going to be drawn inside our inspector using property drawers, and every time that class is going to be used inside your scripts, they will be drawn exactly how you have defined it for the property drawer of that class. This is how our custom inspector for the player class looked after our second video on custom inspector tutorials. I need you to pay special attention to how we have drawn the custom inspector for our shoe information. Coming inside our player class, these were the three variables: shoe name, shoe size, and shoe type, and we were drawing it using these functions. First, we made a label and then we wrote the next three variables in a horizontal layout. Now, instead of having three variables for each shoe, what we can do better is define a shoe class which will contain all the information regarding a shoe. It can also contain some functions that are related to a shoe, and we can use the same shoe class even for the AI, for other players, etc. So we will delete these three variables. Let's hide it by using this command. Now let's also turn off our custom inspector script. Now this is our player class drawn using the Unity default inspector. I have written a simple shoe class. Instead of those three variables in our player script, we have defined a shoe class which has those three variables and an extra variable called name. A few things to note here in the shoe class is that for the field shoe type, I have defined it as an enum. Enums are better than a simple string or an int input in cases when you have a fixed number of variations to your input. So in this case, the shoe type can be of a limited number of options. So if you have an enum, it is easier to code, it is easier to use it in switch statements, in if statements when you are comparing the shoe type to a particular value. The other important thing to note is the system.serializable attribute, which is required for your classes to be shown inside the default Unity inspector. So if I come to my player class and define a new shoe variable, now in order for this shoe variable to show inside the Unity default inspector, right? So this is how the shoe class is shown in the default Unity inspector. And in order to do that for your for the classes that you have created by yourself, you have to use the attribute called system.serializable. The last thing to note in the shoe class is a constructor for our shoe class, which basically initializes all those variables, because when you are writing a property draw for our class, it requires the strings and the ints to be initialized. So what this constructor does is initializes all of those variables. And this is the way Unity default inspector will draw our custom classes. We will have a drop down here, and this label is the same as our class name, and then it will draw all the public variables inside our class in a vertical layout fashion. And our aim is to customize how this class is drawn inside our inspector, and for that we will make a property drawer for our shoe class. We will start by creating a new script inside our editor folder. Let's name it shoe property drawer. And inside our script, there are four things to take care of. First, that you will have to include the Unity editor classes, Unity editor, and we have to write a new attribute called custom property drawer. And inside, as an argument, you will write which class is this a property drawer of. In our case, it is the type of shoe, and all your property drawers should derive from a class called property drawer. Now we don't need the start and update function. Instead of this, the two functions that we have are public override on GUI, which is the main GUI function inside which will write all our GUI elements, which will define how our inspector is drawn. And the next important function is the public override get property height. This function is used to control the height or the space that uh, that your class occupies when it is drawn inside the inspector. The onGUI function will give us some values as an argument. So the rect position here gives us the exact position in screen coordinates where your class is going to be drawn. So if your shoe class is going to be drawn here by the default Unity in the default Unity inspector, it will give you the position of this rectangle here. So using this rectangle, you can draw other GUI elements inside your onGUI function. The next argument is the serialized property. Serialized property is the refers to the object that you are drawing the property drawer. So in this case, this property will is a serialized property of the shoe variable inside our player class. And the last argument is the label, which is a simple label, exactly how we gave label to our float field or our int field. The simplest thing that you can write inside your own GUI function is a simple label. So let's write GUI.label, and it will take the rect position, but we can give it the same position we have got from our onGUI as an onGUI argument, and the GUI content can be a simple string. So let's make it shoe custom drawer. Now this will draw a string in the place where our shoe class was going to be drawn. So here we can see in the place of our shoe class we have a label called shoe custom drawer. One thing that you have to remember is that the rect position that we get from our onGUI function is actually a rect position which is 16 pixels high. So if you imagine this field of the field to input our integer, so this whole rectangle encapsulating this whole field is what uh, the rectangle that our onGUI function gives us. It tells us to draw everything inside that particular rectangle, but we have an option of extending that rectangle. So if we have more content to show, we can extend our drawing area using the second function, which is the get property height function. So let's try to do that by simply adding 20 here. This way it will add 20 pixels to our default drawing area, which is 16 pixels high. So now what we'll have is our drawing area has changed from uh, just 16 pixels high to now 36 pixels high, and we can draw anything that we want inside this area. So Unity gives us a rectangle with the width of your inspector and a height of just 16 pixels to draw everything about your class, all your variables. But we can extend the height and fit as many variables inside that space. We can even write them side by side in a horizontal layout. Let's aim to uh, make an inspector for our shoe class so that the height is 4 times of the default height, and the first line will contain the name. The second line will have both type and size variables in a horizontal layout, and last two lines the last two stacks will be a multi-line description where we will enter a string describing our shoe. One limitation here is that you can't use the automatic layouting system that we have been using in our custom inspectors. So you can't just start by writing start vertical, end vertical, start horizontal, and end horizontal. So what you have to do in this case is to give the exact rectangular position of all of your GUI elements. So if I have to write a label or a string field here, I will have to write the exact coordinate of this rectangle. If I have to write type and size on the same line, I'll have to specify a rectangle for type and this rectangle alongside it for size. The rect position that you get inside your onGUI function refers to this rectangle, where the top left position is your x and y variables from your rect. The width is the width of your inspector, and the height is the height of this rectangle, which is by default equal to 16. Now when you customize the height of your drawing area, which in our case we are going to make it 4 times the size of the default height. In that case, if you have used this function to override how high your drawing area is, Unity will return the height value which is equals to the 4 times your height value. So in this case, what Unity will return is 4h. And uh, if this is our drawing area, this big rectangle here, the in the returned rectangular in the returned rect value, the x and y remains the same because the starting point of our drawing area is same as uh, our default rect. So this point is still x and y. The width is same as the default width, and the height is equal to the height value that we have set use by overriding this function, get property height function. So in our new drawing area, we know the coordinate of our topmost position, the top left position. We know the new height and we know the width. With the help of these variables, we can find the exact rect of each of the GUI elements. So for example, if we have to draw the name field, which is a string field, so this rectangle here, what we need is the exact position of this rectangle, and a rectangle is defined by the top left position and the width and the height. So taking the example of our first field, for this rectangle the x and y are same as our default x and y, which is what we get from our rect position. The width is same as the width, and the height is equal to 1/4 of the total height that we are getting from our rect position value, because when we are overriding our height value, what Unity returns here in our onGUI function is the changed value. So if I have increased it by 20, what Unity will give me is 16 plus 20, that is 36. So when I am drawing this area, the height of this area will be uh, the height that we get from our this total drawing area divided by 4. Using the same logic, if we have to draw this rectangle, if we have to draw a type field here enclosed inside this rectangle, so for this rectangle the width is equal to half of the drawing area. So we can write the width of this rectangle to be equal to w by 2. The height of this field is still same as our topmost field, since we have increased our field to 4 times. So the height of this rectangle is 1/4 of the total height, and the origin of this rectangle, which are the x and y values. In this case, the the x value is still the same because this is our coordinate system. This is the x coordinate axis, and this is the y coordinate axis. So for this point, the x value is still the same, but the y value has increased by an amount which is equal to the height of this rectangle. So we have moved down value which is equal to height of our first rectangle, and the height of our first rectangle is equal to 1/4 the height of our total drawing area. So if our total drawing area's height is 4h, this height will be h, and this point, the y value of this point would be equal to the original y plus this h. Using these same logic over and over again, and it's better if you have the final height of your drawing area as a multiple of the original height. And it is also helpful if you have a graph paper with you, so you can easily figure out the exact rectangular position of all your GUI elements when you are drawing a property draw. And when you have found all those rectangular positions, you can store them in a variable inside your property drawer, and every time that you are calling a function to draw those elements, you will use those particular rectangles. So I have gone ahead and created these four rectangles for each GUI element, which are this first rectangle, my second rectangle, my third rectangle, and this is my final rectangle. So I have gone ahead and wrote the exact position of all these rectangles, and every rectangle which will have four arguments: the x, y, which is the coordinate of the top left, and the width and the height. So I found out the position, the x, y, and the width, height of all the four rectangles. Now the very next step is to find a reference for the variables defined inside our shoe script. So in this case, we have four variables inside our shoe class, and to get the reference of all these four variables so that we can show them in our inspector, we have to define four serialized properties. This method of accessing variables inside our class is similar to the second method of drawing custom inspector, which was using serialized object and serialized properties. So in the same way, we will define four serialized properties. Let's name them same as our variables. So shoe name, shoe type, size, and description. And to get the reference, the function that we are going to use is shoe name is property. The property here refers to our shoe class, and to get any variable inside our shoe class, we will use the function called find property relative, and the argument it takes is the exact name of the variable that we want. So in this case, we want the name variable. Let's check inside our shoe class. So the first variable is called name. So we will write property dot find property relative and the exact name of our variable. In the same way, we will get a reference to rest of those variables. Once we have a reference to all the variables that we are going to draw and all the rectangles where these variables will be drawn, the exact positions, we just have to call either the GUI functions like the editor GUI.property field, which will draw the default fields, the default input fields for our variables. And if we want to draw something specific, which the default Unity fields would not suffice, we can draw using any GUI function that we want. We can draw labels, we can draw a slider in place of normal float field. So we'll start by writing a simple property field for our first three variables. Editor GUI dot property field, and just make sure that you don't use the layout version of these GUI functions. So you can't use editor GUI layout dot label, you can't use GUI layout dot label and other stuff. You only have to use the normal GUI functions like GUI dot label or editor GUI dot label, because these functions require the exact rect values before they can draw anything on screen. So right now we are using editor GUI dot property field for our variable, which is the shoe name. The first argument your property field will take is the rect position, and let's give it our rect top, and the property that we are going to draw is shoe name. Since shoe name is a normal string input, we can directly use the property field, which automatically finds a suitable input field for our variable. And to give it a label, what in the case of property fields, to give it a label to our property field, what we can do is simply write new GUI content and and a string representing our label. So let's name it shoe name, so it's more clear to the designer or our artist. In the same fashion, we'll make property fields for rest two of our variables, and the property field is shoe type, right? Since shoe type was an enum, Unity will automatically find the shoe type and draw a suitable input field for that. And the last one is middle left shoe size, right? Since shoe type and shoe size were small fields, you won't require too much space, so we have packed them in the same horizontal line. And the last one is a description. Here we can't use the normal property field, because since description is a string, Unity will automatically decide that we need a single line of uh, the normal string input for our description. But in this case we need a multi-line string input field. So for that we can't use the property field. Let's first check these three variables, then we will draw our custom description input field. So this is how our shoe class is shown in the inspector. We have the first line, which is the shoe name. We have our shoe type and enum, and in the same line we have an input for our shoe size, and this space is reserved for description, where we will write a custom multi-line input field for our description text. In order to draw a GUI element for our description field, which in this case is of type serialized properties. So to draw serialized properties uh, in a custom GUI element, not as a property field, what we have to do is first convert that property into a type that we need. So to write a multi-line input field, we need a string as an input. But here the description is of the type serialized property. So the first step is to get the string out of our description property. So we can do that by first defining a string field, string description string. So every time that this onGUI function is called, first we will fetch the string data from our description serialized property. Then we will use that string for drawing a multi-line string input. And after we are done, after we have edited the string, we will again feed that string into our serialized property, because uh, when we are writing property drawers, we only have access to the serialized properties. We don't have access directly to the string that is defined inside our shoe class. So we have to do this little conversion from serialized property to a string, make a string input, and then feed it back to the serialized properties. So for our description, the steps are: first, description string. We will take the string out from our serialized property using description, which is a serialized property, and the string value. If we wanted to get out a float value or an int value, if we wanted to make a slider, so we could have written here description dot float value, and in this case it is a string value. And then using this description string, which is of the type string, we can draw a multi-line text input, which can be done by simply writing description string is, and it will take the rect, which is the bottom rect, and the string that we are editing. And once we are done editing our description string, we will feed it back to our serialized property. Description string, no, description serialized property dot string value, and let's assign it back. So this is the way you can draw non-property field editor GUI elements for your serialized properties. Now coming inside our player inspector, we can see a multi-line input field for our shoe description. Now once we have this property drawer for our shoe class, once we have defined it here, now every time we are going to use a shoe class, uh, even in this player script, if we are writing it in our AI script, everywhere we use our shoe class, it will be drawn exactly like how we have defined in our property drawer script. This saves a lot of time when you are working on a big project and your class is being reused again and again.